This module, we're going to be talking about linked lists. And I think you're going to see that linked lists are conceptually very interesting, conceptually very simple, but a fair warning, linked lists can cause a fair amount of consternation in computer science majors. Every computer science major has their story of working with a linked list and it not going well. So I want to warn you guys of that up front. So in this module, we're going to be starting off with talking about what is a concrete data type, and then we're going to move into singly linked lists. And this is where we're going to spend most of our time. The fact of the matter is, if you understand how a singly linked list works, then the doubly and circularly linked lists are pretty standard, pretty simple extrapolations on the base points. So to start off, we need to establish this. What is a concrete data type, or what is a concrete data structure? If you've done your readings, you may have come across things that are implying this, but I'm not certain that our texts necessarily define it explicitly. So let's think about it a little bit. Let's think about what this word can mean, concrete. Well, it can be firm, it can be hard, but it can also be sort of the opposite of abstract. And that's the term that we're using here, right? It's concrete as in it's fully realized and literal. A concrete data structure is a low-level structure that is implemented as a well-defined solution to a problem in a literal way. They are literal manifestations of their design. They cannot be decomposed into lower-level aspects. So what I mean by this is an array. An array is a concrete data type. An array can be thought of as just a sectioned off hunk of main memory. Okay? It is literally a contiguous block of memory that can be indexed. That's it. There's nothing lower going on. There's no metaphor here. Yes, you can decompose an array into smaller arrays or into a single block, but these are still just blocks of memory. These are still just smaller and smaller arrays. There's nothing lower down than that. So, okay, the opposite of a concrete data type or a concrete data structure, then, like I implied, abstraction, abstract data type, abstract data structure. These are data structures that are abstracted off of the lower level system. They describe essential elements of how they behave, describe a system at a higher level, and implement them at that level. They leave the more complex aspects to a lower level system. And their designs are metaphoric. They are analogies. The objects that we implemented in Lab 1, right? They are not literally in the computer memory, right? There's no helicopter, there's no bishop. We're capturing aspects of those things. We're modeling them as objects. Similarly, a dynamic array is an abstract data type. Okay? We can do the same thing. We can break it down into smaller blocks of memory. But the key thing is this. It's not actually dynamically resizing. That's a fiction. Right? Remember, we talked about this. Behind the scenes, a dynamic array is a static array. And if we have a dynamic array with 3, 4 elements in it, let's say, to us, it's going to look like that's it. That's how many elements are there. That's the whole size of the array. It hides the fact that there are extra slots that can be expanded into without needing to expand the array. It hides the process of resizing our array. We don't have to worry about that. And yes, behind the scenes, a dynamic array is built on top of an array. So when we break our dynamic array into smaller blocks of memory, what we're really doing is breaking our static array behind the scenes into smaller blocks of memory. In fact, this is such a core concept in a data structures class that we need to talk about it now in order to understand how they can be used and their importance, right? Both general data types are used almost everywhere. And the key thing is this: we need a concrete data type at some point, but there's nothing against building an abstract data type on top of another abstract data type. When we get to stacks and queues, you will see that we will talk about a stack being built on top of an array, sure, or a linked list, sure, but also on top of a dynamic array. So stack on a dynamic array on top of an array, right? This is okay. This is totally acceptable. And you could build something on top of that stack if you wanted to. There's nothing that prevents that. That is a totally legal way to design your data types. But the key is there has to be, at some point, there has to be a concrete data structure at the bottom. There has to be. There has to be a group of variables or an array or a linked list or something. It can't be turtles all the way down. It can't be that this turtle's on top of that turtle. Well, what's on top? What is that turtle on top of? What's on top of another turtle? It can't be infinite recursion. Understanding the performance of these base data structures, these base concrete data types, is super important so that when we start building abstract data structures on top of them, we can analyze what we're trying to do and what we need to do in a way that will facilitate the design and implementation of our abstract data structures. In fact, doing some of the content that we do in this class is atypical. A lot of schools, the other option in a lot of schools is that there are a series of 2 programming classes before you get into computer science content for real. And in that second programming class, you would do things like arrays in some depth. You would do things like object-oriented programming, maybe some higher order, higher level coding, exception handling, things like that. And then the course that you would take might be called data structures, or it could be abstract data types, or it could be abstract data structures. And then we would just focus on things that are built on top of our concrete data structures. Maybe the first unit would be a review of arrays and linked lists, but then from there we would just start working on stacks and queues and heaps and priority queues and things like that. And these are going to be important topics, and we will talk more about abstract data types in the coming modules, starting with the next module.